So today we're going to talk about the resonance effect. So what is a resonance effect? It is the delocalization of adjacent or parallel p orbital electron. We have two parallel p electron which are adjacent to each other. So the movement of electron, the through electron density of the molecule becomes uniform. So the delocalization of electron, localized means stable, delocalized means not stable. Stable doesn't mean by the energy, stable means by the same position. So the delocalization, delocalized of adjacent p orbital electron. So the electron are delocalized, these electron will shift over here, and this is called resonance. We will look into the very deep what is resonance, but this is general a basic definition. Through resonance, electron density in the molecules become uniform. So if in this pi electron shifts over here, so it will be shifting over here now. This electron will shift over here. So electron density becomes uniform over these, and stability of the molecule increases. Hence, stability increases because electron density is not intensifying in a particular part. Hence, the phenomena of resonance is stabilizing effect. But because of this phenomena of resonance, there is a stabilizing effect. The molecule is being getting stabilized. Here I am mentioning that it is a positive charge and it is also positive charge, which means it is a empty p orbital. Now let's talk about why how this happens and what the particular example I am giving. So let's jump into the resonance. What is a resonance? So resonance we have seen, like there is a benzene. Benzene exists in this form as well as this form. So the delocalization of p electron due to this is called the resonance hybrid. This is the resonating structure of 1, this is the resonating structure 2. These are denoted by this sign, both of the arrow. Now we know here what is the difference between them, that the pi bond here and here the pi bond is here and here the pi bond is here, not at the same position, but the structure are same. Then interconvertible. So we give so these are the method to explain why these two structure exist in the solution. But overall, what structure exists in the solution is called as resonance hybrid. That is called the resonance hybrid. It is denoted like this. So whenever there is a sigma bond, we draw resonance hybrid with a solid line. But whenever there is a delocalizing of pi electron, we represent it as a dot. Dot means it is not a 0 bond, it is not a 1 bond, it is in between them. It could be 1 by 2, it could be 1 by 3, it could be 2 by 3, percentage wise. So let's we will be deeply discussing that. So what are the other examples of resonance? Other examples of resonance like CH3 C double bond O negative. Here this is a pi electron pair, and this will shift because of this, and it will form CH3 CO negative double bond O. And here also CH2 double bond CH double bond CH2. So it is it will shift over here and it will shift over here. So now CH2 plus CH double bond CH2 negative. Now there are some more resonating structure like CH2 double bond CH2 negative charge will shift over here and it will shift over here. CH2 negative CH double bond CH2, and again CH2 double bond CH and CH2 positive. So it will shift over here. It will form CH2 positive CH double bond CH2. So these all are the resonating structure. Now how I am drawing this and how the guess I am doing that it is making a resonance, or means how I am guessing that these will show resonance. So we will discuss deep into that while all these are called conjugation. So in this particular video we are all going to see just the basic primary definition of resonance. So what are the resonating structure and what are the resonance hybrid? So what is the resonating structure? Resonating structures which we are drawing are only hypothetical, but they all contribute to a real structure. which is called the resonance hybrid. A real structure is called the resonance hybrid, and resonance hybrid is more stable than any resonating structure. Resonance hybrid is more stable than any resonating structure. So the resonating structure we are drawing, these all are hypothetical structure. These all are hypothetical. But if we draw its resonating hybrid, like here, this is a real structure. That is the it exists in the solution, but these are hypothetical structures just to explain the real structure and to explain the stability of the molecule. So it is an hypothetical phenomena just to draw on pen and paper to explain the stability of the molecule. So what are the characteristics? Characteristics of resonance. First, it due to which the planar atom should be planar. Second, position of atoms are fixed. Here the atom doesn't move. Third, position of sigma bond is also fixed. Position of sigma bond is fixed. Fourth, pi bond and lone pair can interconverted. Pi bond can be converted into lone pair can be converted into pi bond. So this represents the resonating, or we can say canonical structure. Resonating structure or canonical structure, it is also called canonical structure, and they are resonating structure 1, the resonating structure 2. This is the arrow sign we use. It can move in both the direction. Atoms must have p orbitals or d orbitals parallel. Second, parallel to one another. That is called the conjugated system. That is called the conjugated system. And resonating structure do not completely explain properties of molecule or ion. They do not explain the properties of molecule or ion. So like we have carbonate ion COO negative O negative. So these all structure, this particular structure cannot explain the property. This is one resonating structure 1, resonating structure 2, and we have a third resonating structure, and we can have the third resonating structure as well, CO negative or double bond O, and the resonating hybrid will be CO negative O delta negative O delta negative O delta negative. So these is particular structure RS1, RS2, and RS3 can't explain why there is a negative charge on the oxygen atom, but the resonance hybrid can explain it, right? So 8th point, resonance hybrid can explain all the properties of the compound. And the final point, normally resonance decreases the potential energy, hence increases stability of the molecule. Why it is normally, why it is always? We will see there are anti-aromatic system. We will look on further. There are some anti-aromatic system which decreases the stability then rather than a non-aromatic or a normal conjugation. So we will dig deep into that. This was just the basic definition of the resonance.